I am R.P. Tripathi from Professor Mathematics from KNIT Sultanpur. The topic of my lecture is change of variables. How to change the variables? Change of variables from Cartesian to polar coordinates. The double integral can be changed from Cartesian coordinate x to y to polar coordinate r theta by putting x is equal to r cos theta, y is equal to r sin theta, then the double integral f x y dy dx is equal to double integral f x is replaced by r cos theta, y is replaced by r sin theta. It is Jacobian. Jacobian is nothing but it is defined this dr d theta. Jacobian j is del x y divided by del r theta. Indeterminate del x by del r, del x by del theta, del y by del r, del y by del theta. Differentiate x with respect to r, we get cos theta. Differentiate x with respect to theta, we get minus r sin theta. Differentiate y with respect to r, we get r sin theta. Differentiate y with respect to theta, we get r cos theta. Means determinant, how you find the value of the determinant? It is this into this minus this into this, means r cos theta into r cos theta minus and minus plus r sin theta into sin theta, and it is equal to r cos square theta plus r sin square theta. It is r cos theta is cos square theta plus sin square theta, means it is r. Means Jacobian j is equal to r, means this j is replaced by r. This change is replaced by r. This change of variables from Cartesian to other coordinates. In some cases, evaluation of double integral becomes easier by changing the variables. Let the variable x y be replaced by two variables u v by the transformation x is equal to f1 u v, y is equal to f2 u v, then double integral f x y dx dy is equal to f double integral f f1 f2 Jacobian j du dv. Means if we are required to change x y into another variable u and v, where x and y are related by x is equal to f1 u v, y is equal to f2 u v, then double integral f x y dx dy is equal to double integral f of f1 f2 j du dv, and j is obtained with the help of the previous method which is in the determinant form, where j is dx dy by del u v is equal to determinant del x by del u, del x by del v, del y by del u, del y by del v. Differentiate x with respect to u, differentiate x with respect to v partially, differentiate y with respect to u partially, differentiate y with respect to v partially, we get j, and which is replaced by j is replaced by this j is replaced by after differentiate calculating this. Using the transformation x minus y is equal to u, x plus y is equal to v, evaluate double integral cos x minus y by x plus y dx dy over the region bounded by the lines x is equal to 0, y is equal to 0 and x plus y is equal to 1. Means the upper region upper it is x is equal to 0, it is x is equal to sorry it is y is equal to 0, it is y is equal to 0 means x axis, it is x is equal to 0 means y axis, it is origin and it is x plus y is equal to 1, and we have to transform this region O A B with the help of x minus y is equal to u, x plus y is equal to v. Accordingly, we have to change the limit of integration. Solution: x minus y is equal to u, x plus y is equal to v, that is x is equal to, combine this and this combined, we get x is equal to u plus v by 2, y is equal to v minus u by 2. First we find j is Jacobian and it is equal to del xy by del uv is equal to determinant del x by del u, del x by del v, del y by del u and del y by del v is equal to differentiate x with respect to u, we get 1 by 2, differentiate x with respect to v, we get again 1 by 2, differentiate y partially with respect to v u, we get minus 1 by 2, and differentiate y partially with respect to v, we get 1 by 2. Substituting del x by del u is equal to 1 by 2, del x by del v is equal to 1 by 2, del y by del u is equal to 1 by 2, minus 1 by 2, it is del y by del u, it is minus 1 by 2, del y by del u is equal to minus 1 by 2, it is minus 1 by 2, it is minus 1 by 2, this into this 1 by 4, minus and minus plus 1 by 4 plus 1 by 4 is equal to 1 by 2. It is means dx dy is replaced by j du dv and it is 1 by 2 is equal to du dv. It is the required value of j, means dx dy is transformed to j determinant j du dv 1 by 2 du dv. This the region bounded by the lines x is equal to 0, x is equal to 0, y is equal to 0, x is equal to 0, y is equal to 0 and x plus y is equal to 1. It is OAB is the bounded region. In xy plane is a triangle OAB. Under the transformation x is equal to u plus v by 2, y is equal to v minus u by 2, the line x is equal to 0 get transformed to the line v is equal to minus u, Put x is equal to 0, we get u plus v by 2 is equal to 0, means v is equal to minus u, v is equal to or u is equal to minus v. The line y is equal to 0, put y is equal to 0 in this transformation, we get v is equal to u, The line x plus y is equal to 1 gets transformed to the line v is equal to 1. Here means the transform it is u axis, it is u axis, it is u axis, means v is equal to 0, it is v axis, it is u is equal to 0, it is v axis. Put u is equal to 0, put x is equal to 0, we get u minus v is nothing but it is u minus v, and put y is equal to 0, we get v is equal to u, v is equal to u is analogous to it is v is equal to u or u is equal to v, it is u is equal to v this, and x plus y is equal to 1 transform to, it is x plus y is equal to v, x plus y is equal to x plus y is equal to v, x plus y is equal to v means it is v is equal to, it is v is equal to 1 line, it is v is equal to 1 line means this v is equal to 1 line get transformed to the line this. Thus, the triangle OAB in xy plane gets transformed to the triangle PQR in UV plane. UV plane means it is U, it is V, it is V is equal to 1, it is U is equal to V, it is U is equal to minus 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 V, sorry, it is U is equal to minus V, it is U, it is U axis, it is V axis, it is V is equal to 1, it is V, U is equal to V, it is U is equal to minus V, or U is equal to V or V is equal to U, here U is equal to V or V is equal to U is equal to minus V and V is equal to, it is origin, means this given region transform to, it is PQR, it is P, Q and R, this we get after transformation we get this region, means triangle OAB is transformed to thus the triangle OAB in the xy plane gets transformed to the triangle PQR in UV plane bounded by the lines u is equal to V, u is equal to minus B and V is equal to 1. Draw a horizontal strip AB parallel to the u axis, parallel to the u axis, parallel to the u axis, this parallel to the u axis, which start from the line u is equal to minus V and terminate on the line u is equal to V, means the lower limit of u is minus V, upper limit of u is V, and the lower limit of V is 0, upper limit of V is 1, here this limit of u is u is equal to minus V to u is equal to V, limit of V is V is equal to 0 to V is equal to 1. The given integral I is equal to double integral cos x minus y divided by x plus y dx dy is equal to 1 minus x, u varies as minus u v to plus v cos u by v, because u is equal to x minus y by 2 and v is equal to x plus y by 2, 2 cancelled out we get, and Jacobian j is 1 by 2, means the transformed integral is limit of v is 0 is equal to v varying from 0 to 1, v u varies as minus v to plus v cos u by v 1 by 2 du dv. Since u having variable limit, hence we integrate with respect to u first, cos here with respect to u first means the integral of we integral cos u by v is the integral, this is v, since v is constant, put u by v is equal to t, means du is equal to v dt, v dt means we take v is in the multiplied form, means v sin u by v, and v varies as u varies as minus v to v, u varies as minus v to v, 1 by 2 it is the value of j, v sin u by v. Put v and v cancelled out, we get sin inverse sin 1 minus sin minus 1, sin minus 1 because v it is minus 1 minus v to v means it is minus 1. Sin minus 1 is equal to minus sin minus minus plus means it is 2 sin 1. It is 2 sin 1, 2 cancelled out. Again we differentiate with respect to v, v means we get v square by 2, substituting the limit of v we get 0 to 1, it is 1 by 2, 1 by 2 means it is sin 1, it is sin 1. Second example, evaluate double integral x y under bracket x square by a square plus y square by b square dx dy over the first quadrant of the ellipse x square by a square plus y square by b square is equal to 1. Means we have to integrate this with the help of this ellipse, means the limit depends on the ellipse x square plus x square by a square y square by b square is equal to 1. Here it is x axis, it is y axis, it is 0 0, it is minus a 0, it is a 0, it is 0 b and it is 0 minus b. It is an ellipse and we have to integrate the given integral with the help of this ellipse. Here put x y plane, we get r square is equal to 1 or r is equal to 1, a circle with center this. If we consider the transformation x is equal to ar cos theta, y is equal to br sin theta, the ellipse this in xy plane becomes, after transformation of x is equal to ar cos theta, y is equal to br sin theta, the ellipse, substituting this in the ellipse we get r square is equal to 1 or r is equal to 1, circle with center 0 0 and radius 1 in r theta plane, means we get r is equal to 1. R is equal to 1 is nothing but x square plus y square is equal to 1, means r is equal to x square plus y square. This means we get a circle with center 0 0 and it is r is equal to 1. It is r is equal to 1. The region of integral j, first we calculate j and j is equal to r theta in r theta plane, j is equal to del x y by del r theta is equal to indeterminate form del x by del r, del x by del theta, del y by del r, del y by del r. It is del y by del theta, not del y by del r, it is del y by del theta. It is del y by del theta this. Del x by del r is equal to a cos theta, del x by del theta is equal to minus a r sin theta, del y by del r is equal to b sin theta and del y by del theta is equal to b r cos theta. After calculating we get a, b and r. After calculating this into this minus this into this, we get a b into r, a b into r, a cos theta multiplied, and after solving we get a b into r. Dx dy is equal to j is equal to a b into r, j dr d theta, and it is equal to A B R d r d theta. J is replaced by A B R d r d theta. The region of integration is the part of the circle r is equal to 1, in the first quadrant in the r theta plane. In this region, draw an elementary radius vector OA from the pole which terminates on the circle r is equal to 1. It is the strip parallel to r. OA is the strip, and in this strip theta varies as 0 to pi by 2, theta varies as 0 to pi by 2 in this strip. Limit of r is equal to 0 to 1, and limit of theta is equal to 0 to pi by 2. Integrating the given integral is double integral xy x square by a square plus y square by b square raised power half. It is raised power it is not pi by 2, but it is raised power half this. Substituting fxy it have no power, means x is equal, substituting the given limit we get this. It is the in the question we have x square plus y square, this means we have to convert, we have no power, it is pi by 2. After taking limit we will put this. It is r square, raised power r square, this we calculate a b pi by 2, r is equal to 1 to theta, limit of theta is 0 to pi by 2, limit of r is a b r square x and y, substituting x y and x square by a square plus y square by b square. It is n by 2. 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 It is n. It is x square by this. It is 1. It is n by 2 maybe. It is n by 2. It is n by 2. It is also n by 2. It is also n by 2. It is n by 2, ABR, it is n by 2. It is n by 2, not pi by 2, it is n by 2. It is r square n by 2, it is n by 2. We have a square b square 0 to pi by 2 sin 2 theta by 2 0 to 1 r raised power n plus 3 dr a square by b square by 2, and the limit of again integrate with respect to theta, since both are independent limits, we integrate, the double integral becomes the multiplication of two single integrals. Integrating it we get the given result. Evaluate this, it is n by 2, sorry for this mistake, it is n by 2 over the first quadrant of the ellipse. This consider the transformation x is equal to a cos theta, y is equal to b r sin theta, the ellipse x square by a square plus y square by b square is equal to 1 in xy plane. xy plane, and we get r square is equal to 1. R square is equal to 1 means it is r square is equal to 1 means r is equal to 1. It is r is equal to 1. It is r is equal to 1. Theta varies as r is equal to 1 theta. It is theta is equal to 0 line. It is theta is equal to pi by 2 line. Theta is equal to 0 line is initial line, and theta is equal to pi by 2 is the perpendicular line. Perpendicular line is nothing but it may be approximately say that it is y axis. This the region of the integration is 0 theta varies as 0 to pi by 2 0 and pi by 2. R varies as it is pole r is equal to 0 to it is r is equal to 1, r is equal to 0 to r is equal to 1 means theta varies as theta is equal to 0 to pi by 2, r varies as the region we have already drawn this step. In this region theta varies as 0 to pi by 2, r varies as 0 to r is equal to 1, r is equal to 0 to 1. Substituting this in the given function, this we get, substituting this transformation in the given equation, we get a b r square cos theta sin theta. It is n by 2, it is x square plus y square by a square, it is r square means it is r square n by 2, r square n by 2, and it is not pi by 2, but it is n by 2. It is r square into n by 2 means it is r raised power n. First we integrate with respect to, since both having the independent limits means both limits are independent limits, we take the single limit of with respect to r and with respect to theta we get, and taking limit we get a square plus b square by 4 minus cos pi plus cos theta is equal to 1 by n by 4. The result is a square plus b square by twice n plus 4. Thanks.